Hello everybody and welcome back to another video by Funlearn Tutorials. In this video, let us apply the decomposability property for the Jones 1965 model. Now remember what I told about the decomposability property? Basically, the output system is independent of the price system. Now let us come back to the Jones 1965 model. So we have the four equations that represent the Jones 1965 model, and we have this output system. So we have an output system and we have a price system. What we need to find out for the decomposability property, so basically we are studying the decomposability property in terms of the Jones 1965 model. Decomposability property. Now you might be wondering, so basically decomposability property is a property of the Jones 1965 model. Well, yes, but it's a general property. We are basically trying to see if the decomposability property is holding in the Jones 1965 model or not. The property is essentially that the output system is independent. What we are trying to find out is the property holding here? So is the output system independent of the price system? That is what we are trying to find out. This property is not just true for the Jones 1965 model. We can try and check for this property in many sectors, many models, and we are trying to check this property for the time being on the Jones 1965 model. So if we have to look at the way in which the decomposability property holds or not, the first thing that we have to do is see how the model solves, right? So we have to see how the model solves. Now, how does the model solve? Let's see. So these are the four equations that we have. So let me just number the equations first. Of course, the numbers are not universal. You can name any equation, anything you want. Just because I have written the equations in these number, I am numbering the equations in this order. So you have the output system. These are the two equations. And you have the price system. These are the two equations. Now, let's look at the price side first. So let me have the eraser. Let me remove this and let me keep just the price side. So I want to see how the price side moves. So you see, first, if I look at these two equations, this ALA is a function of W and R. So that means this ALA is actually an expression. It's an expression which consists of W and R being the only two variables. That is why, remember, function is expressed in terms of its arguments or its function or the variables in which it is expressed. So basically, this ALA is actually a function. It's actually an expression of W and R. So let me write that these functions, these ALA, KA, these are all input coefficients. Input coefficients are functions of factor income or factor prices. Input coefficients are functions of factor prices. So what does it mean that they are functions of factor prices? It means that they are an expression. They are an expression that contains only the factor prices. Expressions consisting of W and R. So these two are basically expressions consisting of W and R, which are basically the arguments of these two functions. So what does that imply? That implies that this entire thing that I have written here is actually an expression in W and R. So similarly, this is also an expression in W and R. Similarly, this is also an expression in W and R, and so is this. So if you look at the right hand side of the two equations, this is an expression in W and R, this is an expression in W and R, and you have W and R on this side. Doesn't that mean that this entire section is an expression in W and R? Similarly, this is also an expression in W and R completely. There are no other variables involved. Now, if we have to solve, so I had written solve, right? So if you have to solve an equation, let's see something. In this system that we have 4 equations, right? So we have 4 equations. Now, by a very popular algebraic theory, if we have 4 equations and if you want to solve the 4 equations, we need 4 variables and no more than that, no less than that, no more than that. So, because we have 4 equations, we need 4 variables. Now, which are my 4 variables? In this model that I have, the 4 variables are actually the 2 factor incomes, so W and R, and the 2 outputs, XM and XA. So that means I am considering PM and PA to be constant. Now why? The question is, why are they constant? So of course, these two are constant. The question is, why? The answer to this question is very simple. Remember that for this 1965 model, there was an assumption which said that the economy is a small open economy, right? It's probably the first assumption of the model. So it's a small open economy. Now, questions usually don't come as to what are the assumptions, so we tend to forget that this is a small open economy. This is a very bad mistake, because you always need to remember this assumption. Why? Because this is actually what creates the entire model. How? Small open economy. Where does this word small come from? Remember perfect competition, how every firm is a small part of the economy? That same idea is applying here. In perfect competition, basically because every firm is a small part of the market, they are all price takers. That same logic applies here. Because the economy is small, the economy also acts as a price taker. That means PM, PA are all determined in the world market. So the prices of the commodities are all determined in the world market, and the economy has no control over them. Because where does open come? World market. So the prices are determined in the world market. That is where the open world is coming. And the economy is small. That is why the economy cannot control the prices. So the economy is a price taker. So the world market prices are taken by the economy. That is why it's a small open economy. So PM and PA are constant. So my only variables are W, R, X, and XA. Now coming back to these two equations. So basically, at least for these two equations, the only two variables on this side are W, R, W, R. So if you look at this side, just these two equations. So just for equations 3 and 4. So equations 3 and 4. If you look just at equations 3 and 4, the variables are what? The variables are W and R. There are no other variables for equations 3 and 4, right? And there are two equations. So you have two equations and two variables, so you can solve. You can solve for what? You can solve for W and R. They are the two variables, so you can solve for the two variables W and R. Now what happens? When you find the two equations W and R, you can take these two variables, pick it up and put it in the output sector. So when you do that, when you have W and R, remember these input coefficients are functions of factor prices. So that means if you know what the values of W and R are, since these determine input coefficients, you know what the input coefficients are. So you know W and R from here, you know W and R from here, you know W and R from here, and you know W and R from here. They are all four of them are the same. That means you know ALA, AKA, ALM, AKM. If you know those, you know these four are the same things, right? ALA, ALA, AKA, AKA, ALM, ALM, AKM, AKM. So if you know W and R, you know all these. So that means once you solve equations 3 and 4, let me just highlight. This becomes known, this becomes known, this becomes known, and this becomes known. So once you solve, I'm repeating this time and again. Once you solve equations 3 and 4, let me just write that down. Once 3 and 4 are solved, if you look at equations 1 and 2, input coefficients are constant. Once equations 3 and 4 are solved, input coefficients are constant. Then what is left? XA, XM, remember these were variables. Remember these are variables. So XM and XA are the two variables. So variables are XM and XA. So the variables are XM and XA. L and K are of course given. These two are of course given. They are literally endowments. I've put bar above them. You have no possibility of thinking that they are not constant. So these are also constant. So what do we have? We have two variables and we have two equations. Two variables, two equations. Standard algebra. We can solve the two equations. If we solve the two equations, what are the two variables that we'll get? We'll get XM and XA. So that is how you solve the four equations. You don't start with whatever equation you have. You look at all the four equations and you see, oh, so I have to solve the third and fourth equation first. Use the two values that I get and plug them in 1 and 2, and then we solve for XA and XM. Now you see that now this is where the decomposability property comes into play. The output system has to be independent of the price system. Think about it. Output system means, because these are the variables, these are the only variables that we can control or work with. So suppose for some reason one of these outputs are increased. Suppose XA increases. Suppose, we don't know why, we don't know how. Suppose XA increases. The question is, will not price cannot change because that is determined by the world market. Will W and R change? Are they affected? The question is, suppose XA increases. The question is, will W and R change? The answer to this is no. These two, W and R, will not change. This is true not just for XA, this is true for XM as well. Even if XM increases, W and R will not change. Why? That is a very valid question. The answer is XM and XA are in these sectors. Once you're dealing with these two equations, once 3 and 4 are solved. So you look at equations 1 and 2 only when equations 3 and 4 are solved. So if you're looking at equations 1 and 2, it implies that equations 3 and 4 are solved. If equations 3 and 4 are solved, it implies that W and R are already found. So if you're looking at these two equations, it means you already have W and R at hand. You're taking one, you're holding W and R in one hand, and then you're looking at equations 1 and 2 and seeing what happens. So that means W and R are already determined. These two values are already determined. From where? How? From equations 1 and 2. So W and R will not change. That means if you affect the output sector, that will not affect the price system. So output system is independent of the price system. That means, what does that mean? Decomposability property holds. Decomposability property holds, which implies this property holds in the 1965 model. This is what we mean by the decomposability property in the Jones 1965 model. And that is how you prove this model.